Welcome to lecture 10 of NLP. So today we will start discussing vector semantics. So far we had talked about text representations in which words were represented by scalar values, and the representation for words was not very rich. So we now want to study words and represent them in much more richer way so that we can use them in our analysis. So we'll start with a discussion on lexical semantics, uh, trying to understand why words have different senses and what are the relationships between those senses. And then we will introduce the notion of representing words as vectors, and uh, and how do we will also introduce why or how we can develop those vectors from data. So we first talk about sparse representation using word context matrices, and that will be relatively brief. And then we'll move on to dense representations using word2vec. So today's lecture probably we will be focusing more on the lexical semantics and introduction to word context matrices. Probably we will not be able to start word2vec today since we do have a quiz at the end of class today. So the quiz will start around 2:55. So we have about 50-55 minutes for the lecture. So with that, so let me get started. Any questions? So we will start with a discussion on lexical semantics. So we talked about semantics right at the start of the semester. So semantics is a branch of linguistics that studies meaning. And lexical semantics is the study or the sub-branch of semantics that studies the meanings of words. So lexical, as we already know, refers to the dictionary. So the dictionary contains the list of all the words for a particular language. So, and as we already know, usually we will take the word as the smallest unit of representation in our NLP task. Uh, it could be a word, it could also be a subword, but in many cases, it's just a word, which would typically refer to a word, an entry in a dictionary of that language. So words, as you know, is if you think in terms of orthography, it's just a sequence of characters. Okay, so whenever I write something, for example, LIFE, so it's a sequence of characters LIFE, so L and then followed by I and F and E. If you just look at this, then we don't really know much about the word. We just know that it consists of these. It's a four-character word. The first letter is L, then we have I, and then F, and then E. So there is no other notion of the meaning of this word. And and if you recall, when we talked about the sparse representations of documents, as in which features each feature in that document was a word, then the representation of a word like life was probably given by single scalar like TF-IDF. Okay, this is a scalar representation. It's a number, non-negative number, 0 or higher, that basically tells us how frequently, or it's based on how frequently that word occurs in a given document as opposed to the entire collection of documents. So again, we don't have much knowledge about the meaning of this word. Uh, So we want to build bigger or richer representations of words that capture the various meanings that words may possess. Okay? So any ideas on how we can represent words that would be much more richer and would capture much more details about a particular word. Anyone has a suggestion? All right. Uh, any questions? Okay. Mhm. Okay. So let's talk about lexical semantics a little bit so that you have the motivation for why words have different meanings and the various shades of their meanings. So whenever you look at a dictionary, you have a concept called a lemma. So lemma is basically known as a root word that basically appears as the head word in a dictionary or lexicon. Okay? So, so as you know, morphologically, many words can have various forms. So, for example, we talked about life, for example. So, life, there's a plural form of this as well, lives, although that's not a very common word. Uh, and for example, there could be other words like run, for example, then ran, running. So there are various variations of a word. Uh, and the root word is usually the first word, the basic word that's usually called a lemma that represents that word. Okay? So this is what is meant by lemma. And the second thing is that words have senses or lemmas have senses. And senses basically means a word and a particular meaning. So, for example, for example, each a particular word can have multiple senses. For example, if I write live, so live would be a verb. Okay? So this is a verb, live, and it basically refers to, for example, I live in Lahore. So that's a verb. And then live, again, the same spelling. This would be a noun, for example, a live transmission of a cricket match. Okay? So this word live, which is represented by these four characters, have two senses. I have written one sense is the verb, and the other sense is the live broadcast sense. And whenever we capture the relationships between words, we should actually capture relationship between senses rather than words because there, in this case, word live has two senses. So if I want to uh, relate live with, for example, life and live will life, for example. So live versus life. So I need to know which sense of live I'm using. Is it the live broadcast sense or the live sense? ठीक है ना? So relatedness of the live sense would be greater with LIFE than the sense that we use for live broadcast of any event. ठीक है? So relationships exist between senses of words, not actual words. So relations exist between senses, word senses. So you have to be clear which sense that is being referred to while when you are trying to relate two words. ठीक है? So two concepts that we have studied, lemma. Lemma is the root word that is typically used as the head word in a dictionary, and then all its variations would be written below it. And the other thing is whenever you are relating two words, we should explicitly mention which sense of that word you're talking about. Because relationships exist between senses rather than words. Okay? Okay. So with that, let's briefly discuss some relationships that are commonly present in linguistics, and from there we'll motivate why we need richer representations. So anyone can tell me a very common relationship between words? You must have studied this in your English classes right from, let's say, school time. So, so synonymy, for example. So this concept of synonymy, so two words are similar, not identical, but in general similar, okay, in meaning. So again, when I say word, we are talking about specific sense of those words. So for example, good and great can be considered to be synonyms. For example, big and large can be considered to be synonyms. And you can have various other examples as well, uh, right? So synonyms basically means that two words and their specific senses have similar meanings. But one other concept in linguistics is that whenever we say they are similar, they are always never identical. ठीक है? तो कुछ shades हैं, कुछ variations हैं, कुछ connotations हैं. We will discuss these terms later on as well. There's always some difference. Cultural usage difference है उसका, या demographic usage difference है, या historical perspective different है, कुछ meanings different है. There will be some difference. But of course, similarity है तो we call them synonyms. And in many cases, we can use one instead of the other in text. ठीक है? So obviously, when we say two words are synonyms or sets of words that are synonyms, we can also introduce the notion of similarity. So this is a computational notation. What is the similarity between word one and word two? ठीक है? So similarity would capture synonymity, or intensity, or whatever you want to call this. ठीक है? But again, this is just one aspect of relationship. So there are other aspects as well. For example, you all know about antonyms, antonymy. So opposite meanings. Okay. So you know, have the example of good, for example, and bad, and small and large, for example, and so on. Okay. So can we use similarity to maybe represent antonymy? Perhaps yes. Maybe low similarity, you can say it's uh, not very similar. It's not. It may be opposite, but that is not always the case because words may have other relationships as well. So, for example, there's a notion of polysemy, or let me talk about. So, for example, hyponymy. So this relationship is the relationship between two word senses. One word is a subclass of another word. So subclass, so for example, dog and animal. So we can say dog is a subordinate or subclass of the word animal. ठीक है. So of course there may be some similarity, but they are obviously not synonyms, and they are also obviously not antonyms, and in this particular case they are hyponyms. ठीक है. So similarity would not capture this notion accurately. ठीक है. So similarly, we have what is known as uh, the concept of polysemy. So what is polysemy? Words that are identical in orthography, in spelling, in spelling, but different in meaning. Meaning that a word may have multiple senses. So ये वही वाला concept जो पहले हम कह रहे हैं, words have senses. So they may be words that have different senses, even though they might be spelled the same way. So इसमें various examples आप ले सकते हैं. For example, bank. ठीक है. Bank, this is a financial bank, financial institution, or for example, the one related to, for example, a river. ठीक है. Same meaning, same word, but meaning may be different. And then, of course, you have many examples. For a bat, for example, bat is an animal. Bat is also the bat that you use to play cricket. You can think of ring. Ring is the ring that person wears on his finger. It could be the bell ring, the sound of ring. Ring the bell, rang the bell, which would be a verb. The first case would be a noun. ठीक है. Same orthography, same set of characters, but different meanings. ठीक है. So in this particular case, आपको meaning किस तरह पता चलेगा? From just a layman terms, and of course from a computational perspective, we'll talk about it later on. तो एक particular बैंक का meaning, बैंक लफ्ज आपने देखा है text में, तो how do you know which meaning is being followed? Anyone? Is this referring to a institution, financial institution, or a? So for example, I played cricket with a bat. So how do you know that this bat refers to the bat that is used for play cricket? Because you look at the context in which it is used. Similarly, a bank. So I went to a bank to draw some money. So that would be the financial institution. I went to the bank for a picnic. That would be the river bank or some lake bank. Okay? So context helps us. And we will kind of use this extensively in computational aspects to derive the meaning of words. So polysemy, hyponymy, there are other relationships as well. Let me just mention one more. Homonymy. Okay? So these are words that have the same, both things, actually say subclasses, and words that have the same sound or spelling but are different in meaning. So इसमें जैसे ऊपर polysemy जाता है where the words have the same spelling, वो वाला भी इसके अंदर आ जाएगा. But इसमें दूसरे भी आ जाएंगे. So for example, ring is also an example, bat is an example. ठीक है. But you also have words like weight and VGHT. ठीक है. Both are sounding the same, but they are different. ठीक है. Spellings are different, but there are also those that have the same spelling but have different sounds. For example, जो live हमने देखा था पहले, वो live, but इसको हम live पढ़ेंगे, right? So again, same sounds but different meanings. sorry, different spellings, sorry, same spellings and different sounds and different meaning. ठीक है? So this whole exercise showed you that words have relationships between their senses, and those relationships can be quite diverse. Synonymy is something that we are very familiar with, but there are many other kind of relations. Antonymy is opposite, hyponymy, class, subclass relationship, homonymy, and then there are others as well, meronymy and so on. We don't want to go into the details, but this is just to motivate that words have meaning that are very rich. Uh, Continuing in this way, we have a few other things. Uh, there's a notion of what is known as a semantic field. Okay? So sometimes we can group words into various semantic fields. Okay? And within a field, the words may be related. We will not use the word now similarity, we use the word related. Related according to a semantic field or related according to a particular जो ऊपर मैंने रिलेशंस बताई हैं हाइपोनीमी हो गया या मेरोनीमी हो गया या एंटोनीमी हो गया सो सो वर्ड रिलेटेडनेस vs word similarity. So word relatedness is a broader relationship or broader concept, and that may capture additional notions of relationships to synonymy. Okay? So semantic field, as I said, a concept uh, you can say containing related words. So for example, if you talk about the concept of, let's say, education, so this is a concept education, इसमें words related होंगे. For example, teacher, student, class, course, all these words now belong to the semantic field of education and they have some relatedness. They may not be synonyms, they may not be antonyms, they may not be other things, but they have this relationship according to this concept of education. Okay? And of course, these concepts or the semantic fields can be defined according to our needs. Okay? So it could be smaller or it could be broader. So for example, जैसे मैंने education की बात की थी, तो if I define a even more specialized concept, let's say university, उसमें कुछ वो वाली टर्म्स भी आ जाएंगी बट इसमें कुछ एडिशनल भी आ जाएगी फॉर एग्जांपल semester, so for example GPA, for example professor, all of these would now be related under the concept of a university, which you can say this concept of university is a sub concept of education. ठीक है? तो इस तरह की आप हायरार्कीज भी बना सकते हैं. सो अगेन फॉर एग्जांपल हॉस्पिटल का आप लें कंसेप्ट, तो उसमें फॉर एग्जांपल नर्स होगा, पेशेंट होगा, एंड सो ऑन, डॉक्टर एंड ईटीसी. ठीक है? Similarly, that one, okay, so much of this semantic relationship between words is often coded in detailed dictionaries. And one very popular dictionary is called a WordNet. We are not going to talk about this in great detail in this course, but it's a useful resource for working with words. So WordNets would it's basically is a graphical structure. Of course, this is a computational इसके API मिल जाती है, सब कुछ आप कर सकते हैं. इट्स अ कंप्यूटेशनल स्ट्रक्चर. सो वर्डनेट है, इसमें सारे वर्ड्स हैं इंग्लिश के, डिफरेंट लैंग्वेजेस के भी मिल जाते हैं. एंड इसमें फिर सारी रिलेशनशिप्स भी आपको दी हुई है कि इज दिस ए हाइपोनिम ऑफ दैट, इज दिस ए एंटोनिम ऑफ दैट, मीनिंग्स भी दिए हुए हैं, एग्जाम्पल्स भी दी हुई हैं. तो वर्ड नेट इज़ अ वेरी यूजफुल रिसोर्स. और ये इन 5-10 years बैक ये हम वर्ड नेट काफ़ी डिटेल में पढ़ाते थे इन एनएलपी कोर्सेज, बट अब इसकी थोड़ी सी यूजेज कम होगी, सो वी डोंट टॉक अबाउट much in detail resource for NLP. ठीक है. So WordNet is a very popular resource for NLP, which would, and of course, is available for different languages. It has words, it has relationship between words and their senses. It has glosses, which basically refers to the meanings of those words and how they are used. And it's a graphical structure. ठीक है. API available, you can use it in your applications. Okay, one last concept is the concept of connotation. Before we move on, connotation. So connotation, so words may have connotations, and connotations are you can say, I don't know what word to use. So connotation is connotation. Uh, so for example, a word like forgery, what connotation does this word conveys? Is it a positive connotation or a negative connotation? So this will give you a negative connotation. So similarly, there might be other words, for example, uh, for example, कोई simple word लेने good ले लें तो this is positive connotation obviously. ठीक है. So words may have connotations as well, and these are very useful whenever you're doing sentiment analysis. So positive connotation words would uh, typically refer to a review or a sentiment that is positive, and negative connotation words would uh, refer to a negative review. And sentiment and connotations की भी databases available हैं. So for example, there is something called a senti word net. So this word net has details on the connotations of words. It's a word net, but it has been augmented with connotation information useful for sentiment analysis. And of course, there are others as well. So there are also sentiment lexicons available. So you can Google them and you can find many sentiment lexicons. मतलब वो वर्ड में ग्रुप किया हुआ है कौन से वर्ड्स पॉजिटिव हैं कौन से नेगेटिव हैं या कितनी पॉजिटिव पोलैरिटी है किसी की कितनी नेगेटिव पोलैरिटी है. ठीक है. सो many of these are already available and easily usable in your application. So generally जब हम sentiment analysis and connotations और इस तरह की चीज़ों की बात करते हैं तो we actually talk about three things. एक तो polarity है, पॉजिटिव है नेगेटिव है और कितनी पॉजिटिव है कितनी नेगेटिव है. इसको हम समटाइम्स बैलेंस भी कहते हैं. अगेन टर्मिनोलॉजी थोड़ी सी डिफरेंट है. एंड सो पोलैरिटी क्या है उसकी वर्ड की. एंड सिमिलरली आई डोंट रिमेम्बर द एग्जैक्ट वर्ड. इंटेंसिटी कह लें. द सेकंड वन माइट बी द इंटेंसिटी. ठीक है. एंड द थर्ड यू कैन से कि उसका इम्पैक्ट क्या है. सो ईच वर्ड इफ यू वांट टू हैव for each word you can think of three features for that word. एक उसकी इंटेंसिटी बता दें. फॉर एग्जांपल गुड है तो उसकी पोलैरिटी पॉजिटिव होगी. लेट्स से बाइनरी रिप्रेजेंट किया हुआ तो 0 1 हो जाएगा. तो इट विल बी 1 लेट्स से गुड के लिए. तो इफ यू टॉक अबाउट गुड ये 1 हो गया. इंटेंसिटी सम स्केल लेट्स से गुड मींस लेट्स से स्केल 0 to 5 में स्केल 4 होगी. एंड इम्पैक्ट सो मतलब हाउ डज a particular word impacts the rest of the words in a particular sentence? Is it extremely impactful कि उसका सारा सेंटेंस का मतलब चेंज कर देता है या सिर्फ उसका इम्पैक्ट थोड़ा होता है? तो दिस इज व्हाट इज रेफर्ड बाय अगेन यू कैन क्वांटिफाई दिस इन सम वे, मे बी 0 to 5 में इसको मैं 2 दे देता हूँ. तो इस तरह आप डिफरेंट वर्ड्स के लिए आप कर सकते हैं. So now what you have here is a word, but for each word you now have three values representing that word rather than just one value. You can now this is like a richer representation as opposed to let's say TF-IDF जिसमें one scalar value थी और उसमें for example इस तरह की चीजें भी included नहीं थी. ठीक है? So we want to go towards these richer representations. So for example, you can even think of representation that you can make handcrafted representations. So for example, पहला आपका फीचर बना ले पार्ट ऑफ स्पीच है, तो लेंथ ऑफ करेक्टर्स हो गया फॉर एग्जांपल फीचर. दूसरा हो गया लेट्स से वही जो पोलैरिटी की मैं बात कर रहा था उधर. मे बी यू कैन इवन इंक्लूड थिंग्स लाइक के हम नंबर ऑफ कैप्स, कैप्स कितने हैं उसके अंदर एंड सो ऑन. डिपेंडिंग ऑन द एप्लीकेशन यू कैन डिफाइन फीचर्स फॉर ईच वर्ड. रिमेंबर हम पहले फीचर्स डॉक्यूमेंट्स की बात कर रहे थे, हम वर्ड्स की बात कर रहे हैं कि एक वर्ड को हम रिच रिप्रेजेंट करना चाह रहे हैं. ठीक है? सो फॉर एग्जाम्पल जब हम गुड की बात करेंगे तो पीओएस इसका क्या होगा? गुड इज बेसिकली एडजेक्टिव. ठीक है? लेंथ ऑफ कोर्स 4 कैरेक्टर्स है. पोलैरिटी 1 है. नंबर ऑफ कैप्स इन दिस केस इज 0 एंड सो ऑन. नाउ यू हैव ए representation that captures more information about a word rather than just how many times it occurs in a document. Of course, you can have those. So you can also include TF here as well. ठीक है? टर्म फ्रीक्वेंसी भी एज ए फीचर यूज हो सकती है. ऑलराइट. So the whole point of this discussion was to motivate you to uh, the diversity of meanings of words and the lack of representation that we have studied so far. Meaning that so far we have represented words by just one number, which was usually TF or TF-IDF, that did not was not able to capture the various ways in which or various shades of meanings within a particular word. Okay? So we want richer representations for words. So richer representations for words are needed. ठीक है? अब इसमें दो चीजें हैं. एक तो हमने ऑलरेडी देख लिया कि वेक्टोरियल रिप्रेजेंटेशंस आर हेल्पफुल. ठीक है ना? इट्स नॉट जस्ट वन स्केलर वैल्यू, इट मे बी मल्टीपल स्केलर वैल्यूज एंड यू कैन एक्चुअली increase the number of features as needed. ठीक है? So vector जब representations करेंगे then you also have the notion of embeddings. किस तरह कि वेक्टर के मतलब से 2D वेक्टर है लेट्स से, तो 2D स्पेस में वो एक वर्ड एक पॉइंट बन जाएगा. ठीक है? 3D तीन फीचर्स हैं तो 3D स्पेस में एक पॉइंट बन जाएगा. 100 फीचर तो 100D स्पेस में एक पॉइंट बन जाएगा. सो एवरी वर्ड वुड बी रिप्रेजेंटेड as a point in some space defined by the number of features. ठीक है? So that representation in space is called an embedding. And by looking at two words or 2 points in a space, we can actually compare how related they are. They may not be similar, but they may be related in some way. ठीक है? So we have vectorial representations. So let's say मैं W1 is a vector and W2 are two, let's say, vectors of, let's say, length, let's say 100 for, uh, let's say good and great. ठीक है? So both of these would now be represented by a point in space, and the relatedness between them, W1 and W2, can be captured by one technique that we already saw before, using the cosine, which is the angle between the two words, right, in that space. But this is not necessarily similarity, but it's relatedness. ये relatedness ये भी हो सकता है कि जैसे in this case both, actually in this case both words are similar to some extent. We know that great is like a synonym of good. But ये और word भी हो सकता था. For example, W1 मैं कहता हूँ कि let's say nurse है, and W2 मैं कहता हूँ patient है. Of course, these are not synonyms, but their relatedness would be high because they both belong to a semantic field, which is which refers to that these words are used commonly in the same context. ठीक है, so इनका relatedness W1, so nurse, and दूसरा था patient, would be generally large. ठीक है. So again, this is not similarity, not necessarily similarity, but it's relatedness. ठीक है. Okay. So we talked about we can represent richer representations using vectors. Now, what is the other idea here? हमको मीनिंग्स कहाँ से पता चल सकती हैं rather than looking up the dictionary or wordnet, कोई और तरीके से भी हम मीनिंग्स इन्फर कर सकते हैं? Any ideas? लगता है लोग बहुत थोड़े हैं ऑनलाइन. ठीक है. So ठीक है. So how can you capture meanings of words by looking at large amounts of language written in that large amount of text written in that particular language? So of course, one way is that you can look up WordNet, or you can do some processing on WordNet or some other resources, NLP resources. But more common approach nowadays is what is known as distributional semantics. Meaning that inferring meaning from their usage in context. ठीक है? So that is, the first idea was vectors, meaning the richer representation. Second idea was, of course, when we talked about vector, we said that we can also do handcrafting of the features. जैसे मैंने पहले कहा POS टैग एक फीचर बना लें, POS एक फीचर बना लें, लेंथ ऑफ वर्ड बना लें, connotation बना लें, and so on. But that is cumbersome, time consuming, may not be accurate. So we would like to automatically learn those representations. And we will use the idea of distributional semantics, which is that you can infer the meaning of words by looking at the words around it in and looking at the context in which that word is being used. ठीक है? So as such, we can learn the representation in some way rather than handcrafting them. ठीक है? So this is a major step forward, and it has been around, by the way, in NLP for decades. It's not, the concept is not new. Of course, the idea of word to vec is new, but ये concept जो था is old. Distributional semantics की, by the way, I think very uh, I think there's a very good textbook way back in 1956 that proposed this. So it's not an old, it's not a new concept. Okay, so now let's look at the first way of learning these representations. And this will lead us to sparse vectors. Okay? So we will talk about word dash context matrices. Okay? And actually we have seen an idea of this before as well. By the way, uska quiz bhi aapka aa raha hai abhi. Word document matrix, for example. So word document matrix is an example of a word context matrix in which the context is a document. ठीक है? वो किस तरह था? For example, let me just write it. Let's say if you have three documents, D1 है, D2 है, D3 है, and then word 1 है, word 2 है, word 3 है. So you can count, or you can count the number of times that word 1 occurs in document 1. For example, it occurs 10 times. In document 2, it occurs 0 times. Document 3, let's say 5 times. So 2 की मैं बात करूं तो let's say ये 1 है, ये 5 है और ये 5 है. W3 की बात करूं तो let's say ये 0 है और ये 5 है और ये 10 है. So now we have this matrix in which we have a representation for W1, W2, W3 that defined by these three documents. And these three documents represent context. And we have a vector for these documents. Now, W1 का a vector of size 3, W1, W2 का भी size 3 है, W3 का भी size 3 है. And then we can maybe use cosine similarity, cosine to find the relatedness between these two words based on how they are used in these three documents. Because we know that if a word is used repeatedly in the same document, it means that they will be related. Okay? And so cosine would be able to quantify that. Okay? So this is the idea of word context matrix, and we have already seen this in the idea of creating document matrices. ठीक है? So अब by the way मैंने अब word का एक वेक्टर लिया, वहां हम कॉलम वेक्टर ले रहे थे रिप्रेजेंटिंग ईच डॉक्यूमेंट. तो D1 का जो वेक्टर था वो जो कॉलम बन रहा था उसका W1, W2, W3 से which one W1 would be a feature, W2 would be a feature, W3 would be a feature, would be a vector for the document based on the words it has. You can flip this and you can think of words and the features are D1, D2, D3. और words का जो vector बन रहा है, this is a vector that represents the word based on the context in which it appears. ठीक है? Now you can think of this as a representation for each word rather than representation for each document. So इसको by the way हम एक step आगे लेके जाते हैं. So this was just to motivate you कि हमने ये पहले देखा हुआ है. ठीक है? So word context usually होता है based usually जो context होता है, so words close to a particular word. अब ये closeness किस तरह हम define करते हैं? Usually using, let's say, plus C and minus C words around a word W, where C of course is a integer greater than 0. तो ये context window define कर रहा है. ठीक है. So let's say if I write a running test, let's say I live in Lahore. ठीक है. And let's say मैं +1 और -1 कॉन्टेक्स्ट विंडो की बात कर रहा हूँ. तो देन जो लिव है वर्ड, इसका कॉन्टेक्स्ट क्या होगा? इसके कॉन्टेक्स्ट में आई आएगा, इसके कॉन्टेक्स्ट में इन भी आएगा. ठीक है. वन वर्ड बिफोर, वन वर्ड आफ्टर. ठीक है. व्हाट अबाउट आई? आई आई का ऑफकोर्स लेफ्ट कॉन्टेक्स्ट कोई नहीं था, तो उसमें सिर्फ राइट वाला में वर्ड आएगा आई लिव. ठीक है. सो इन की मैं बात करूं तो उसमें आई लिव एंड लाहौर एंड सो ऑन. लिव इन आ गया, लाहौर लिखूं तो इसका इन है. So these are the contexts for these specific word based on the specification that we define a context as one word before or one word after. And this C plus C minus C is called the context window. ठीक है. So you notice that कि आपके जो actual word है वो जो मैंने पहले लिखा है कॉलम में, वो भी word है, context में भी word है. ठीक है. वर्ड है, context में भी word है ना. context में पहले document था, context में भी एक word है. So you actually now get what is known as the word matrix. ठीक है. सो वो किस तरह? सो लेट्स से यही वाली एग्जांपल ले लेते हैं, छोटी एग्जांपल. लेट्स से मेरे पास कॉलम्स हैं. आई लिव इन लाहौर. और मेरे पास जो रोज हैं वो भी आई है, लिव है, इन है और लाहौर है. बट ऑफ कोर्स माय कॉर्पस वुड बी वेरी लार्ज. ठीक है ना. बट फॉर दिस स्मॉल एग्जांपल. ठीक है. सो आई का कॉन्टेक्स्ट ऑफ कोर्स आई एंड आई वो उसी कॉन्टेक्स्ट में आ रहा है, वन. आई लिव में भी एक दफा आ रहा है. एंड देन ऑफ कोर्स इन में जीरो है, लाहौर में जीरो है. ठीक है. तो लाइव में आई में भी आ रहा है, लाइव ऑफ कोर्स वन है. इन में भी आ रहा है, लाहौर जीरो है. ठीक है. सो इन की मैं बात करूं, जीरो, वन, वन, वन एंड जीरो. एंड लाहौर की बात करूं तो जीरो, जीरो, जीरो एंड वन. ठीक है. ऑफ कोर्स ये मैंने सिर्फ एक सेंटेंस के बनाया, बट यू विल बिल्ड दिस फ्रॉम ए लार्ज कॉर्पस एंड यू विल गेट नंबर्स, raw counts. So these are all raw counts. So those raw counts will tell you how similar, how related two words are based on the context in which those words appear. So you can take a row as a vector, even you can take a column as a vector. Remember, दोनों जगह words ही हैं. तो आपके पास एक्चुअली दो रिप्रेजेंटेशन आ गए, और दोनों सिमिलर होंगी. तो आप एक रो भी ले सकते हैं, एक कॉलम भी ले सकते हैं. ठीक है. सो आई जस्ट स्टॉप इन अ कपल ऑफ मिनट्स. ठीक है. ऑफ कोर्स इफ यू डू दिस फॉर ए लार्ज कॉर्पस, so build this for from a large corpus. ठीक है. So in the number of words would be of course vocabulary size. ठीक है. So the matrix would be basically v time v in size. ठीक है. Vocabulary size typically for a corpus, reasonably large corpus, is going to be large, 20,000, 30,000, 50,000, 100,000. And context window जो हमने ली है, usually वो, so usually जो C जो होता है, टिपिकली हम लेते हैं, फॉर एग्जांपल 3 ले लिया, 1 भी ले सकते हैं, बट 1 इज लेस कॉमन, 5, 7, मे बी 11 एंड सो ऑन मैक्सिमम. तो कॉन्टेक्स्ट विंडो रिलेटिवली छोटी होती है. So you are not going to find every word in the context of every other word. So this vector or this matrix that you get was going to be sparse. So this is going to be a sparse representation. Just like the word document matrix that we talked about earlier was sparse. It's going to be long, meaning that vocabulary size 20,000, 30,000, 100,000 lamba vector hai. And then there will be lots of zeros in it because every word would not appear in every other word's context. Okay? But still, since we have used context, this vector would be able to capture meanings in a much better way. And you can take the cosine similarity of two vectors to find the relatedness between those two words. So I think I will stop here. And so this part that I'm doing is chapter 5 of your textbook. So this chapter 5 will be covering it almost entirely completely. In the next lecture, we will start with the word to vec, which is a dense representation of meaning for words. And it will be based on neural networks that we have already studied before. So that was one of the reasons why I covered neural networks before, uh, because its understanding using neural networks is much easier as compared to using logistic regression. ठीक है तो वो हम पढ़ेंगे and then a little bit about history of embeddings and word to vec and then we will move on to other topics. But next class में probably mostly word to vec ही होगा cover. ठीक है so are there any questions? ठीक है तो आज ऑनलाइन लोगों ने बहुत कम लोगों ने ज्वाइन किया हुआ है सो विच इज़ काइंड ऑफ प्रॉब्लमेटिक तो लेट्स सी बट आप लोगों का क्विज भी था बट क्विज आप क्लास में बैठ के क्या कहना चाहिए उसको फॉलो भी कर सकते हैं द क्विज वुड बी आफ्टर वी एंड द लेक्चर ठीक है ठीक है सो